Okay, we have some match pairs. We have some, I think this was BP before and after a medication was administered. And the idea being that the medication hopefully lowers BP. So, or whatever this is. This is what I get for pulling it randomly out of the book. But anyways, we want to see if this medication works. It's supposed to lower this value. So then our null is that there is no difference. So that before equals after. But our alternative is going to be that before is greater than after. We want to prove that way. We want to prove that, okay, it actually went down, something like that. Now, to do this in Excel, we're going to go over to Data, Data Analysis, and I'm going to go down to t-test paired. Okay? I'm going to click on, and I'm going to put in, so in my case, A1 through A13, B1 through B13. My hypothesis mean difference is 0. Labels. Now you can change this. This normally comes up at 0.05, but for like medical stuff, I usually do 0.01, and I wanted to put it over an N1. So then here's our t-stat, 2.34. And then we can look, this is a one-sided, one-tailed test right here. So I'm going to look at that and go, can I prove this? Well, my value is not greater than that, so I can't. And I can see that my p-value here is not less than 0.01, so I would have to fail to reject at a significance level of 99% here. This does give you the two-tailed ones. These t-values will match what you've been doing in the book because you can see your df, because it's a paired, is 11 just like we've been using. So these will be exactly the same as what we've been getting if you've been doing them by hand. If you use the independent ones, the DFs will be a little off. We've been doing a different method, so you might want to go back and do those, but this will match exactly what you've been doing by hand. So we would look at this and we'd have to fail to reject that we can't prove that it does lower it based on this data. The reality probably here is they just need more data, and that might be your recommendation.